Hey, my name is Alex Sindel. I'm a GIS student at Selkirk College in Castlegar, British Columbia, Canada, and I want to share with you the final project that I just completed for our Python programming class. My project's called PetroPal, and basically it's a way to calculate the cost of gas for anybody commuting to Selkirk College. Selkirk's located, as I said, in Castlegar. It takes up this sort of promontory here, sticking out into the Columbia and Kootenay rivers. And as you can see, it's fairly isolated, so there's definitely a sort of unusually high degree of vehicular commuting among Selkirk students, let's say. Of the 18 students in our class, I'd say at least 2/3 live beyond the Castlegar area. So looking at the sort of general West Kootenay district here, we've got a lot of students up in Nelson. A lot of students living in the Castlegar and Nelson Carter, and then quite a few down in Rosslyn and Trail, and some sort of spattered throughout the area. So if we want to calculate the cost of gas associated with commuting to a location, we need three things. We need to know the cost of gas per liter, we need to know the distance that you're driving, and we need to know the fuel economy of the vehicle that you're driving. So I've incorporated those three things into my Python program with different functions, and I'll give you a quick sort of overview of how it works. Then we'll have a look at it in action. So looking down here at the main function, which kind of calls all the other functions, we've got a couple of inputs. One is the year, so that's going to start us down the path of figuring out the fuel economy. Then we've got some we've got this is valid function that just takes care of making sure your input year is viable. But let's skip over that and look down here. So we've got car make, another important input to figure out fuel economy. And then this function here, the get economy function, actually is what starts things off and provides you with the fuel economy for your car. Now how that works is, as you've seen, we've inputted the year and make of our car, and the get economy function essentially, based on the year you've input, opens and looks through a CSV file containing basically a record for every car manufactured that year and its associated fuel economy. So if you enter 1999 and Toyota, it's going to open that CSV file, look through it, and pull out the records for anything that has Toyota in it, and then print that back to you. And then you select the appropriate fuel economy for your vehicle, and that gets inputted in the next line here. Fuel economy equals input, enter the fuel economy for your vehicle. Location is the next input, so that asks you for your home address, and that is then run through the get location function. This relies on a module called PyGeocoder, which essentially taps into the Google Maps API and allows you to return the latitude and longitude location of any address anywhere in the world, which is quite amazing and handy to have. So that returns your geographic coordinates. Distance. So here we're getting into the figuring out the distance driven part. So this basically uses the get distance function to figure out how long of a commute you have, and I'm quite pleased with this function. I'd say it's my favorite. What it does is it takes the latitude and longitude coordinates that the get location function figured out for your home address, and it measures the distance between that point and the latitude and longitude coordinates for a list of about 60 reference stations that I chose in the West Kootenay. And so let me explain what I mean here. So here's kind of an overview of all of them. And so anywhere there's significant populations, and along the highway, as I placed sort of points. This map here is basically just to sort of give you an example of what it looks like. It's not really an input in any way to the program. And each of these points has basically the important thing is that it has a known geographic coordinate and a known as driven driving distance from that coordinate to Selkirk College, and that's just based on what Google Earth says the shortest distance is. And so the get distance function calculates the distance between your home address and the locations of all of those different reference stations, and it's basically calculating a great circle, or as the crow flies, distance, and it figures out which is the shortest distance and basically takes that reference station and utilizes it to determine the as driven distance for most of your commute, so between that reference station and Selkirk. Then it adds the as driven distance from that reference station to Selkirk with the as the crow flies distance from that reference station to your home. And because the distance between your home and the reference station is apt to be pretty small, the overall distance estimate is quite accurate. It's within about 1% of what Google Maps or Google Earth would predict the distance driven from your home would be. Of course, there's going to be certain rare occasions where this sort of strange topological thing is going on. The reference station is across a railroad track from your house or something, and you have to drive a long way around the railroad track to get to the reference station. But for the most part, it's pretty accurate. So now we've got the fuel economy of our car, the distance, and we're ready to move on. Commuters. So this basically takes the number of commuters that are using the vehicle, so it can account for any carpooling that's going on. Days. This is an input to determine how many days a week you're commuting to school. And the next function here is get gas from web. So that basically opens a website called, I think it's bcgasprices.com, and searches it for the current average cost of gas, regular gas, for the province of British Columbia, and then returns that. And then basically this commute cost function here just sort of pulls all those different things together and calculates the cost of gas for your daily commute, and then it prints everything out. So let's have a look at the program in operation. Oops, bear with me. So first we're prompted to enter the year of the vehicle we drive. So say I drive a 2001 vehicle, and say it's a Toyota. Enter Toyota. It's going to give me a list of all of the Toyotas manufactured in 2001 in North America, at least. So I drive a RAV4. It's a two-wheel drive RAV4, and it's the manual model, so I get apparently 8.7 liters per 100 kilometers. So I'm going to use that as the input for this next line here, enter the fuel economy, and then I'm prompted to enter my home address. Now, let's just say I live at the library in Castlegar. I'm going to enter library Castlegar, BC, and as I said, because we're using the Google API, it's pretty flexible in terms of what you can enter, so this should work just fine. Enter the number of commuters, including the driver in the vehicle. Usually, I'm embarrassed to say it's just me, and the number of days a week I commute to school, so that would be about 6. Yeah. So, Toyota with fuel economy of 8.7 kilometers per 100 liters, just for reference, and it tells me what I want to know. The cost of gasoline for your round-trip commute of 19.15 kilometers is $2.05 per person per day, and that equates to about, well, to $12.30 per person per week and $196 per person per semester. So you can see, even for a relatively short commute, the cost of gas does add up. If we were to run that again real quickly and chose somewhere a little bit further afield, say Rossland, and say I was driving a fairly large car, say a Nissan Pathfinder 13 point, oopsie. It's gonna add up. So say I live in Rossland, BC. Say I drive alone 5 days a week. So yeah, you can see here the cost per semester is over $1,000 just for gas. Anyway, that's PetroPal for you. Kind of a useful tool if you're a Selkirk student, but Otherwise, not so much. Nonetheless, I'm fairly pleased with it, and I'm pretty excited to learn a bit more Python and tinker around with things a bit more. Anywho, thanks for listening, and I'll catch you later.